Welcome to Public Health on Call, a podcast from the Johns Hopkins Bloomberg School of Public Health, where we bring evidence, experience, and perspective to make sense of today's leading health challenges. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes.
Hey listeners, it's Lindsay Smith-Rogers. Today, pharmaceuticals and other chemicals in our wastewater. Carsten Prasse, a Johns Hopkins environmental science researcher, talks to Stephanie Desmon about his work looking at innovative ways to keep as much of these compounds as possible from reaching our drinking water and the fertilizer that feeds our crops. One idea? Using common mushrooms to degrade the drugs before they can re-enter our food and water supplies. Let's listen.
Carsten Prasse, thanks so much for joining me.
Thank you for having me today.
So I wanted to know this. What happens to the medications we take and the products we use after they go down the drain? Most of us assume they just disappear, but they don't. And trace chemicals can make their way through wastewater systems and back into the environment. Today, I want to talk to you about an unexpected solution that you found in your research. Today, we're talking about how fungi can help remove things like pharmaceuticals and personal care products from wastewater. Why does this matter?
It matters because if these things aren't removed from our wastewater, then we are potentially exposed to them. So, for example, through drinking water or potentially also food that is grown using wastewater.
Medications like antidepressants and beauty products, they don't fully break down. And so some of it ends up in these water systems. Can you quickly walk through an overview of how wastewater treatment works and where it falls short?
People need to really realize that things that we flush down the toilet, they don't necessarily all just disappear. But many of these things actually end up in our environment. What happens to the wastewater when we flush it down the drain or down the toilet is that it typically gets into wastewater treatment plants. And these treatment plants are designed to remove things like nutrients and just the bulk material that's in the water. But unfortunately, at least the way these are designed today, they don't really remove many of these pharmaceuticals. So they are still present in the treated wastewater, which is then typically discharged into our rivers. So that's why downstream of wastewater treatment plants, we often can detect things like pharmaceuticals and other things. Very important thing is that people need to keep in mind is that we are also producing another byproduct during wastewater treatment we call biosolids. So these are the solid waste byproducts, and that people can think about as these are bacteria that we use to clean the wastewater. The challenge here is that many of the chemicals that we are flushing down the drain, they might stick to these biosolids. And then we commonly use biosolids in agriculture as a fertilizer. And there's a good reason. Biosolids, they are high in organic carbon, they're high in nutrients, so it is a very good fertilizer. But an unintended consequence is that if we use these in agriculture, there are also all these other chemicals that are potentially present that we then have on our agricultural fields where we grow our crops, for example.
So these chemicals can end up in the crops, in the food itself, back in the drinking water?
Potentially, yes. So that's actually a study that we also recently published where we looked into a small set of pharmaceuticals that are commonly found in wastewater, where we actually looked into the plant uptake. And we were able to demonstrate that some of these chemicals are indeed taken up into plants. We looked into carrots, tomatoes, and lettuce specifically, and we found the chemicals also in the plants. The good news in the tomato and carrot case was that we found them primarily in leaves. I say good news is because we don't typically eat the leaves of tomato plants and of carrots. But in the salad case, there's a potential exposure concern because we are eating the leaves. And I mentioned biosolids are used in agriculture, but I also want to mention that an increasingly used practice is actually to use the treated wastewater, also for irrigation purposes. Mm-hmm. And that's particularly in regions of the world where we have water shortages. So in the US, for example, in California or in the Middle East, for example, like Israel, a lot of the original studies on plant uptake have actually come out of Israel because of the fact that it is a very common practice there.
So then we're concerned about what's getting back into our systems.
Correct, yes. And from our research, I think it's not only just the pharmaceuticals themselves, but it's also potentially the metabolites. So plants similar to us can metabolize these compounds and form metabolites. And these metabolites are staying in the plant as well. So in addition to the pharmaceuticals themselves, we also then have to think about the potential risks of the metabolites. I want to say, though, that at least based on our study, we can't really say anything about the risks. Our focus was really just to see, are these things potentially taken up? Are these metabolized, and what are these metabolites? In order to really do what we call risk assessment, we really would need actual concentrations, need to analyze plants that are actually grown on fields, because our study, we used plants basically in the laboratory under somewhat controlled conditions. There's a lot more work necessary to actually determine if there are any risks, but it's certainly something that we think is important to look into in the future.
So let's take a little bit of a step back. What makes them so good at removing these compounds?
In general, fungi play a very important role in the environment because they can degrade organic materials that other microorganisms like bacteria, for example, often can't. So the best example that people can maybe think of, if you walk through a forest, for example, and you see fallen trees, you often see fungi actually growing on these trees, and that's because they can actually degrade wood, for example. And so we thought these very special abilities that fungi have, maybe they're also able to degrade some of these pharmaceuticals that most bacteria, for example, can't degrade. And this is actually not something that we have come up with. People have looked into this before, primarily in more like controlled studies in the laboratory, basically in a petri dish. I think what we have really demonstrated is that we can really use this to degrade certain chemicals on these biosolids that I mentioned earlier.
So how did you do this? What did you actually find?
So we basically grew 2 different mushrooms, for example, oyster mushrooms, on biosolids in the laboratory. And then we added different pharmaceuticals to them. And we basically monitored over time how these compounds are degrading, and then also if there are any basically metabolites that we form. So similar to what I mentioned earlier with the plants, also fungi, they degrade them, but degrading doesn't necessarily mean that these compounds totally disappear. But there might be other products that are forming. And that's also something that we would look into. What I would say is, what was very encouraging from the study is that all the compounds that we looked at were actually degraded by the fungi. So that's something I think very promising. We only looked into a small set of psychoactive pharmaceuticals. There's many more in our wastewater, or many also, we talked about personal care products and other things. So I think this would have to be evaluated more broader, basically, for other compounds. But at least for the things that we were interested in, we definitely saw degradation. So I think that's overall pretty promising.
In this case, when the fungi are employed, are they making those chemicals disappear? What are they doing, do you think?
Well, no, they don't make them disappear. They're degrading them to other things. But based at least from our assessment, it looks like that most of the things that are forming are more benign than the original compound. So again, from that perspective, it looks like it can be really a promising approach. And the other thing that I also want to mention is that, and that's something we didn't look into, but I think that would be something to look into further in the future, is that when these fungi can degrade things that are not degraded by bacteria, the metabolites that they form might be actually degradable by bacteria. So they can, so to say, work together to actually potentially completely remove these compounds. So that is something that I think would be important to look into the future, especially in the context of biosolids, if they are used in agricultural field. So if they would be, for example, treated with the fungi before, and then you would land apply them, and then you have these bacteria that are growing in our soils. So maybe they can actually then completely degrade them.
So what could this mean for the future of wastewater treatment in agriculture?
So biosolids, they are an important fertilizer. They definitely have important use. If we use biosolids, we have to use less of fertilizers that are, for example, produced by synthetic means, which are often very costly and also energy intensive. So they use a lot of energy to make. So we basically can offset this. The other aspect is also that biosolids, again, these are byproducts of our wastewater treatment plants. We generate pretty large amounts of them in the US and worldwide. And if we wouldn't use them in agriculture, we would have to think about what else could be used. They could be incinerated, which is very costly, or put into landfills. But that's also a problem because landfills, again, we would probably reach the capacity of landfills. So with our approach, we hope that we can reduce potential environmental impacts that these biosolids have. So that's the main thing that we are hoping, or we want to pursue further with this research.
there are still some chemicals that are much harder to break down, even
Yes.
with the fungus.
Mm-hmm.
What are those?
Yeah, I mean, I think the main class, and most people have probably heard of them, or at least I hope they have heard of them, are the so-called forever chemicals or per- and polyfluorinated compounds. So these are used in Teflon and other things. And they have been all over the news because, for example, in Maine, unfortunately, there were several farms that had to be shut down because there were biosolids applied. Now, one thing I want to mention is that these biosolids that were applied, they were not just the common ones that are coming out of our typical wastewater treatment plants. These were coming out of the paper industries, and so they had very high concentrations of PFAS. We actually did a study where we also looked into PFAS in biosolids more broadly, and typically PFAS, we find them, but they are typically present in very low concentrations. So I think that distinction is important just from the perspective of potential concern. Again, I certainly want to mention that for PFAS, at least with what we looked at so far, with the fungi that we looked at so far, these PFAS, they can't be degraded. So we still need something else, forever chemicals.
So what you shared really sort of highlights how connected everything is, right?
Mm-hmm.
What we use, what we throw away, what comes back into our environment. Mm-hmm. What's the one thing you want people to take away from this?
We have all these chemicals in the environment, and we can blame, our wastewater treatment plants that they don't do a good enough job. But I think the main thing to really think about is that we are the reason that these chemicals are present in the wastewater because we use them in our households. So just thinking about when people think about all the things we use in the shower, detergents and cleaning agents and so on. So I think the main thing that I would really encourage people to do is think more about the chemicals that they use in our daily lives. And are they all necessary? Are there potential alternatives? For example, using biodegradable chemicals like in detergents, for example. There is a move more and more into also kind of promoting these things. So I think that's definitely, in my opinion, the most important aspect to think about. That it's on us individually. And then I think in general, obviously, we need a better way of assessing chemicals that are being used. So I certainly don't want to put all the burden on having to look into each product that we use in our households on the individual, but we rather need a better system that really helps us assess are the chemicals that we are using in all of these products potentially of potential concern for the environment, or as I said, potentially to us, right? Because if we don't degrade them in the wastewater treatment, they might get into rivers, they might get into drinking water, and so we are exposed to these things again. So it's kind of like it's a circle, basically. So we really have also to think about minimizing the release of chemicals that are harmful, either for us or for the environment.
What I'm thinking as I'm listening to you is about antidepressants. So that's something that ends up in the wastewater and is something that the fungi can make some effort toward, but there's still this issue is that these chemicals are coming back to us. Those are harder to avoid for people who use them.
Correct. Yes. It has to be a more nuanced discussion about, and I think pharmaceuticals is one class. I mean, they're very important. I mean, just thinking back about my grandparents, unfortunately, they don't live anymore, but my grandparents lived to old ages. And one reason was that they were taking quite a few pharmaceuticals. I remember when I was younger, coming to my grandparents and seeing these boxes of pharmaceuticals. And again, obviously, I'm happy that they had them because I was able to enjoy my grandparents much longer than I might have otherwise. So yeah, I think pharmaceuticals is probably a bit of a tricky conversation to have, even though I think also there are efforts to actually think about or including this, what we call green chemistry, so making pharmaceuticals in a way that they can degrade, for example, in the environment. But I think there's many other compound classes that we use. I mean, again, thinking about detergents or personal care products, where I think there's much more opportunity there because, again, pharmaceuticals they're life-saving, right? So it's a bit, and that, in my opinion, has and should have priority, whereas with other compounds, that is not necessarily the case. So I think, at least from my perspective, that's how I would approach this or think about it.
Carsten Prasse, thanks so much for joining me. This has been really interesting.
Thank you for having me again.
Public Health on Call is a podcast from the Johns Hopkins Bloomberg School of Public Health, produced by Joshua Sharfstein, Lindsay Smith-Rogers, Stephanie Desmon, and Rachel Walsh. Audio production by Michael Bonfils, Matthew Martin, and Philip Porter, with support from J.B. Arbogast, Spencer Greer, and Chip Hickey. Distribution and social media by Rachel Walsh, with support from Nick Moran and Brianna Iacovelli. Follow us on Instagram and Blue Sky at Public Health Pod for more public health takes and special content. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes. Thank you for listening.